maybe not. Okay, so
Yeah, until 4:30.
subtract 23 and 1/8 and minus 9 and 9/44. So here's the thing. Right off the bat, I need to know what denominator I need to work with first. That's your first thing. So when you're doing subtracting, you need to make sure the denominators are the same. Okay? So your first step here is to take 8 and 44 and find what? The lowest common denominator. The lowest common multiple. Same thing. Okay? So, what goes into both numbers? 2, because they're even. 2 goes into 8 4 times. 2 goes into 44 22 times. What goes into 2 and 22? Or 4 and 22? 2. How many times? 2 and 11. What goes into 2 and 11? Nothing, right? This is your L. This is your LCD. Okay? So what is your LCD? It's 2 times 2 times 2 times 11. Or 2 cubed times 11. Or 8 times 11. Or 88. Okay? Well, that's nice to know, but how do we get there? So again, 23 and 1/8, well, I'm sorry. We're going to go this way with it. 23 and something over 88. And this is going to go minus 9 and something over 88. Now, at this point in the game, it's not that hard to look at 8 and go, oh, 11 times 8 is 88. And it's not that hard to look at 44 and go, well, 2 times 44 is 88. Okay? But I'm still going to talk about why. Why is it working out that way? So, again, your LCM is this, right? This whole thing. Okay? 8 is 2 times 2 times 2. So your LCM is 2 times, or your LCM is 88, right? So it's 8 times 11. 8 times 11. And that's why we can take 11 and 11 and find 11 over 88. Because 11 times 1 is 11, right? And then we want to do with the 44. Well, again, we're going to take 11, or the 44 is 11 times the 4, and what's left? The 2. 2 times 44 is 88, and so we manipulate the fraction by a 1, and we get 2 times 9, which is 18. Okay, so now we've got it. Although I still can't do it. So I'm going to bring this down here. I'm going to rewrite it as 23 and 11/88 minus 9 and 18, 88. And why can't I subtract them? What's wrong? What's wrong with the 11 minus 18? What's 11 minus 18? It's negative, right?
Yeah.
Yeah. We don't want to deal with negative fractions inside a positive number, right? That's confusing, okay? So what we have to do is we need to borrow from this. So we're going to borrow from the 23. So we're going to make it a 22, and we're going to add 1 to this. So what we're going to really do is say 88 plus 11, because we're adding 1, and 88 from the bottom. That's how many 1 would be, right? 88 over 88. So we're saying 88 over 88 plus 11 over 88, and we're saying it's going to be 22 and 99 over 88. Does that make sense? Minus 9 and 18 over 88. And now it's not that bad. So now I've got 99 minus 18 over 88, and I've got 22 minus 9. Which means I have 22 minus 9, which is 13. Right?
Yeah.
And then I have 18 from 88, so 8 from 9 is 1. And 1 from 9 is
1
no. 8?
or 8.
Yeah, or 8. Okay. So 13 and 81, 88. But am I done? I mean, hey, you're almost done. You might even be done. But you have to make sure of something. And I'm going to take it to another board so I don't mess up. And that something is, I need to make sure I need to make sure I got 13 and 81 over 88. What I really need to make sure of is 81 over 88, is that reduced? So again, use our manipulative tool. 81 and 88, does any number go into both of them? So I see if 2, well, they're not even, right? So 2 doesn't work. What about, remember my 3 things? 2, 3, or my 6 things? 2, 3, 5.
7.
Yeah.
Not 11.
Yeah.
13.
Good.
How come 9 ain't in there?
Ah, because what goes into 9?
Oh, 3.
It's not that they're odd. It's that they're prime. No other number goes into them except themselves. That's what the definition of a prime number. So I checked 3. Well, what's 8 plus 1?
9.
9. So is 81 divisible by 3?
Yes.
Yes. What's 8 plus 8?
16.
Is 16 divisible by 3?
Yes.
16?
Or
Now what's 6 plus 1? To just 7, right? Well, is 7 divisible by 3? No. See, if you're not quite sure, you just take that number. I know that 8 plus 8 is 16. So 1 plus 6 is
7.
7. Is 7 divisible by 3? No, so none of this is. Okay? So then I go to 5. So now 3 doesn't work. Does 5 work? No, why? 0 and 5. 0 and 5. That's how we know about 5s, right? What about 7? Well, 7 you just have to do. So I know that 7 times 11 is 77, right?
Yeah.
And 77 and 81, well, 77 isn't 7 away from 81, is it? So I know 7 isn't going to work. Okay? So I'm at 11. 88 works for 11, but 81 doesn't work for 11. So now I'm at 13. Do I need to do 13 or not? Remember, this is 121, right? What are these numbers? Are they between 49 and 121? If they're between their squares, right, then that's as far as I have to go. That tells me that those numbers, there's no other number that goes into them. So, boom, I'm done. And that is reduced. And now I know that it is. So what happens on the test if you get to the bottom, you get to the end, you put it like this, and I'm just going to change it real quick. I'm going to change it. I'm going to change it a little bit. 13 and 81 over 89. Oh wait, my bad. Wrong way. 81 over 87. Okay? And you go, hey, that's done. Okay? Well, let's look at it. Is 81 over 87 done? 81, 87. And you go, wait a minute. 8 plus 1 is 9, right? 3 goes into it. What's 8 plus 7? 15. 3 goes into that. So 3 goes into both of those numbers. So I would be able to break this down, right? Yeah. Into what? Well, 3 goes into 8. 2 times with 2 left over. Yeah. And 3 goes into 21. 7. 3 goes into 8. 2 times with 2 left over. And 3 goes into 27. 9. 9 times. Okay? Now what about these numbers? Are those numbers done? Does any number go into 27 and 29? Well, 3 goes into 27, but it doesn't go into 29, because 29 is prime. Okay? I know that, but you would go through the same thing. Where is 27 and 29 at on our thing? Well, this is what? This is 9, and this is 25, and this is 49. So we'd have to go up to 5 to figure it out. So 2 doesn't, 3 doesn't, 5 doesn't, and then 7 doesn't. And once I go to 7, it does. Then I know, because of right here, 5 and 7, it's a number that lies between the squares of 5 and 7, that it doesn't go in. And so I'm able to break this down into that. So it's 13 and 27 over 29. And so this can be reduced. And remember what I said. I was just making this number up. The problem did break down to this, and this is the actual answer. But just in case on the test, what if you left it like this and you could have broke it down? Then you're going to miss 2 points out of 5. Because you did the job of what you were supposed to do. You subtracted them, and you did a great job at it. But you didn't do the other half of the problem. And the other half of the problem wasn't just about subtracting. It was also about reduction. Okay? So I need to be able to reduce the answer appropriately. Okay? Now, what if you went through all this, right? And you showed me that, oh, it didn't go through, but it did. But you made a mistake. Well, then, instead of missing 2, I'll be like, well, you tried, and I see that your math, oh, you just messed up on a math. It was simple. You knew what to do, but you failed in what you did. Well, then you're only going to miss 1 of the 2 points. Because I know you knew what to do, it was just you made a simple mistake in how you did it, which caused you to get the problem wrong. So simple mistakes will give you small portions off on the test. But big mistakes where you don't even try get you bigger portions off. Okay? All right.